What is the phase and temperature of water with a specific volume of 0.3939 cubic meters per kilogram and a pressure of 0.6 megapascals? Try solving this problem yourself before watching the solution up next. This is the second example for the TV diagrams and property tables 13-minute lecture video. The links to the other examples on this topic and the other lectures of the Thermodynamics course are found in the description below. In this case, we have the pressure and specific volume information, and we want to find the phase and temperature. Every time you're given two values that are not completely apparent for you to say compressed liquid or superheated, it's wise to start at the saturated liquid-vapor mixture table. Since in this case what we have is pressure, we use the saturated table by pressure, not by temperature. We know that we are looking for a pressure of 0.6 megapascals, which is the same as 600 kilopascals. But what in the table are we looking for? Well, since what the other information we have is specific volume, we're going to check for VF and VG. If our specific volume is lower than VF, we have a compressed liquid. If our specific volume is greater than VG, we have a superheated vapor. And if we have somewhere in between the two, we have a saturated mixture. In this case, Vg is equal to 0.3156 cubic meters per kilogram. Since our given specific volume is 0.3939 and therefore greater than that, we know that our water is in the superheated phase, and more importantly, that we need to use the superheated tables to find any information we're looking for. We go to the superheated tables and we see that they are organized by subtables for different pressures and rows for different temperatures. We go to the 0.6 megapascal subtable, and since what we have is the specific volume, we look for that 0.3939 number. When we find it, we see that it corresponds to a temperature of 250 degrees Celsius, and therefore that's our temperature. In the main lecture, we discussed that we'll learn about interpolation in the lecture after these examples. If our given specific volume was not exactly one of these, interpolation is what we would have had to do here. The examples to the next lecture, interpolation and mixture quality, will include these scenarios, so make sure to check the links in the description below if you want to check those out. Thanks for watching!